In this example, I want to solve the equation x plus 5 all raised to the 3/2 power minus 27 equals 0. So it's another problem involving a rational exponent, a fraction in the exponent here. And again, my first goal, let's say, is to isolate the most complicated part of this equation, which is this x plus 5 to the 3/2 power. So I'm going to move the 27 to the other side of this equation. So I have x plus 5 to the 3/2 power equals 27. Now, just like with the previous example, I want to get rid of the exponent. The way to do that is to raise both sides to the reciprocal power. So I see 3 over 2 here. I want to raise both sides to the 2/3 power. So on the left side, I have the power 6 over 6, which is just first power. So I have now just x plus 5. So we've gotten rid of the fraction in the exponent, at least with regard to this expression of x. Now over here, again, here's where you have to pay close attention to what power you take of the constant term. So because we're raising it to an even power, we're squaring both sides. Remember that when you square both sides, you may get those extraneous solutions. So we need to watch for extraneous solutions. Whenever you square both sides of an equation, you open yourself up to that possibility that these extra solutions sneak in that don't actually satisfy the original equation. Now we're taking a cube root, so we don't need a plus or minus. We have an odd root that we're taking of this side, so no plus or minus in front of our value this time. Okay. So 27 to the 2/3, no plus or minus on that because we're taking an odd root. Actually evaluating that, so it's power over root. So this is the cube root of 27 raised to the second power. When you're evaluating a cube root, you're looking for what number do I raise to the third power to get 27? 27 is, it's 9 times 3, so that's 3 times 3 times 3. So 27 is 3 to the third. And it's nice to be familiar with your perfect cubes. So 1 cubed is 1, 2 cubed would be 2 times 2, which is 4, times 2 would be 8. 3 cubed, as I just demonstrated down here, is 27. 4 cubed, so 4 times 4 is 16. If you multiply by 4 again, you get 64. And I'll just do one more. 5 cubed would be 25 times 5. That's 125. Cubed is 125. Okay, it's just nice to be aware of those perfect cubes, so when you run into them, you recognize them. So 27 is a perfect cube, and its cube root is 3. So this is equal to 3 squared, which is 9. So x plus 5 is equal to 9. Now, to get x by itself, all we have to do is subtract 5 from both sides, and we get x equals 4. But the one last catch with this, it's possible that this is an extraneous solution. So we, in this case, must check to be sure that we're not looking at an extraneous solution. The solution set might be the empty set. We might have no solution. So plug it into the original equation in order to check it. So if we plug in 4 for x, 4 plus 5, all raised to the 3 over 2 power minus 27. We want to verify that we get 0. We're wondering if we really get 0. So this is 9 to the 3/2 power minus 27. So this is the square root of 9 cubed minus 27. Well, this would be 3 cubed. That's 27. Yeah, this is 27 minus 27. 27. So we do get 0. So this is a valid solution, and it's our only solution. X equals 4.